Today we'll be talking about labeling a triangle and Pythagorean theorem. So we're just gonna start off with the formula for Pythagorean theorem. So it's gonna be a squared plus b squared, my bad, equals c squared. So that's your formula, and then we're just gonna talk about labeling a triangle because we need to label all the points for you to be able to solve for Pythagorean theorem for one side of it. So Pythagorean theorem only works on right-sided triangles. So these triangles are always going to be 90 degrees. So we're going to have a triangle right here. Let's just say we have a triangle right here. This needs to be 90 degrees. And we will know because there's usually a box on the side which indicates that the triangle is 90 degrees. And so when we're labeling the triangle, C is always the longest side. So this is C. So C is always the longest side, and this is called the hypotenuse. So this is C right here. And then C is always located on the opposite of the right angle square. So we have the right angle square right here, and it's located opposite of this. So let's see how it's opposite, and that's how we know. All right, so now that we know the hypotenuse, we can identify the other two sides. So these two are actually interchangeable. So you can call this A, and you can call this B, or you can call this B, or you can call this A. So usually what I like to do is I like to keep my triangles consistent. So I'll always call the short side that's always up is A, and the other side is B. But it's really optional for what you want to do for this. And then, so these are always going to be the shorter side. So A cannot be here. Just make sure A is not on your hypotenuse side, or you'll be getting your equation wrong when you solve for one of the sides. And you should usually be provided with, if you're using Pythagorean theorem, you're provided with two sides to be able to solve for the other side. So if I'm provided with one side here, the A side and the B side, I should be able to solve the C side. So we're just going to do some labeling the triangle practice. So I'll be drawing, I'll put up a bunch of triangles, and then you're just going to be practicing yourself and identifying and labeling the sides. So we got a triangle here. We'll just say this is 90 degrees. It's not perfect, but it is. So you're going to draw this out and label what side is A, what side is B, and what side is C. So just think about it for a minute, and then you can write it down. Maybe you have a piece of scrap paper, and we will just go over all of these triangles and just label as many as you can. If you need help, just continue watching the video. I'll be explaining it later, and just label as many as you can. All right, so we'll give you a bit of time. I'll finish drawing all of these first, and then you're just gonna solve. All right, so we have these 6 triangles, and feel free to pause so you can finish, label it up. And I guess since I'm a little short on time as well, I'll just go over them right now. So feel free to pause if you haven't finished, label the triangles. So we have a bunch of triangles here. So this one, there's a square, so we know that this is 90 degrees. And then, so we're gonna label our sides. So this is always the longest side. This is our hypotenuse. It's the longest out of all of them. This is gotta be our C. Oops, let me turn that off. So this is our C. This can be our A or B, and this can be our A or B. So for this, I'll just put A here. That's a really ugly A, and this as B. All right, we're gonna move on to the next one. So we see this. There's no 90-degree indicator, and it doesn't look like it's 90 degrees. Sometimes triangles look like they're 90 degrees, but they're not. So this is not, here, we'll use red. This is not 90 degrees. So, and now let's just move on to the next one. So over here, 90 degrees. So this is going to be our C. And then since we want to stay consistent, we can keep this as a B. It's okay if you labeled A for this. And I would label A for this over B. So it's optional. All right, moving on to the next one. I don't know why I did this, but this one's also not 90 degrees because there's no indicator that it is. All right, moving on. These are kind of like tricky. These ones are kind of tricky. Just make sure you know that they're not 90 degrees. All right, this one, We're going to label the longest side, so it's the opposite of the square, and it's the longest side. So this is our C. This is our B. We'll just say this is B. And this is our A. And for the last one, there's no square, and it doesn't look like it's not a 90 degrees, so it's just not a right triangle. All right, now that all of these are done, we can start moving on to the formula. So for the formula, we know that it's a squared plus b squared equals c squared. So this can be written differently if you're solving for sides. So let's say we're solving for b. I'm just gonna draw a quick triangle because I don't have that much time. So c, let's say we're given c, not c squared, c, and we're given b. Then we can solve for a. So if we're gonna solve for a, then we need to isolate a. So we have this formula out here, and what we can do is we need to isolate a, so we need to leave a on one side, and we need to move the b on the other side. So it says plus b squared on this side. So what we can do is we can subtract b squared and move it over to the other side so we can solve for a. So right now we'd rewrite the equation. So if we're subtracting b squared over there, we'll be subtracting b squared on the other side. So right here, we're going to have a squared equals c squared minus b squared. And this is how we're going to be able to solve for our unknown a side. This is our unknown a side. That's how we're going to be able to solve for it. So it can also be written differently. So with that, we wrote it as a squared equals c squared. That's a bad c, minus b squared. So at the end of the formula, we know that we still need to separate the a squared. So what we can do is the opposite of a squaring it is square rooting it. So we're going to have our a, and then we're going to equal. So if we're square rooting it on this side to cancel this out, we need to do it on the other side to cancel the other side out as well, because we're doing it on both sides. So this cancels with this, and then we're left with a equals the square root of c squared minus b squared. So this is for if we're solving a. If we're solving for c, so we have our a squared plus b squared equals c squared. So if we're solving for c, we're gonna do the same thing. So we're gonna cancel the square root out. So we're gonna cancel the square out. So we're gonna square root it. I'm gonna draw a better square root. Square root it. So we have the square root on this side. So we're gonna square root this on this side. So this cancels out with this, and then we're left with this, a squared plus b squared equals c. So we're going to have that. So just make sure you know how to move your equation around, or you can watch that again, and we can go over it. So I'm just going to draw a triangle. We're going to do a little bit of practice. So we have a nice little triangle here. Nice right angle. I don't know why it does that. So this is 90 degrees, 90 degrees, beautiful. And now we're gonna have one side. So this is 25, let's say this is 25. And then let's say our other side is also 25, which it doesn't look like it, but we'll just call it that. Sometimes it's like that. The drawing's a little weird, but you make sure you look at whatever is given to you. So let's just say this is 25 and this is 25. So we're going to be solving for c, which is going to be our hypotenuse. So because we don't know what our c value is. So we're going to write down our formula. So we have a squared plus b squared equals c squared. So we're going to be solving for c. So some teachers might want you to put in a specific order. So since we're solving for c on one side, I'll just make it simple and just flip it over. So a squared plus b squared. So now we're solving for c. We're solving for c right now. So you can write it out. There's kind of two ways you can solve it. So some teachers might want you to derive the formula. So we're gonna square root this, square root of a squared plus b squared. So then you can just plug it in your calculator all at once. But sometimes teachers might want you to do it separately. So I'll just do it the separate method because it's not that far off. So what you're gonna do is you're gonna c squared is equal to a squared, which is 25 squared plus 25 squared. So that's our first thing. Now we can multiply 25 times 25 and we get 625. So 625. And then this is also 625 because you can just multiply them both together, or you can square them. And then we'll just write c squared so we don't forget c squared. Now we need to get rid of the c squared, so we can show our work by square rooting it and then canceling it. So that cancels with that. So square root cancels with the square. So we get c, and then if we do something on one side, then we have to do it on the other side. So we have to square root this equals the square root of this. 625 plus 625. So now we're gonna, but the thing is, you have to add the insides first, because if you do it, you can do it you can't do it separately. Just add it up first. So we're gonna add 625 with 625. So c equals square root, and if you add them both, you should be getting 1,250, and then you're gonna square root this. You're gonna use your calculator, of course, because with some numbers you can square root in your head, but some numbers it's a little difficult, unless you're crazy. I'd advise you to use a calculator. So c equals, so we square rooted this and we get 35.35. So usually what I like to do is write all the numbers down that I can possibly in the calculator. So my calculator gives me this many digits, so I get all of these. And then for my final answer, I'll just say it's a round. So we're gonna round it up. We're gonna make a reasonable round up. So I usually round up to the second decimal place, so the 100th place instead of the 10th place. But I guess you can do that if you really wanted to. So you get 335.36. So this is how I got my answer. And then if you're rounding to the 10th place, then you're gonna get 35.4. And then you just to double check, we're gonna make sure to see if there's any units. No units, because if this had meters or this had meters, our final answer would need to have meters or we'd be wrong. And then sometimes there's also conversion, so you might have to convert meters to centimeters or anything like that, or centimeters to meters. So just be aware. Right. Now we're gonna do one more question. So let's say we have this. I'm gonna do the same thing, same triangle, but different numbers. So this is just a practice. So I'm gonna make this a little more difficult and then say F, E, this is E, and this is G. So our hypotenuse is G, F, and then E. So now we're given other variables. So this might look a little more confusing. So let's say we're given these. So G equals 24 centimeters. So how are we going to solve this? So if you know how to do this, you can pause the video, finish it, and then we can go over it at the end. But if you're not as confident or you still have questions, we can run this over. So we know that our regular formula is a squared plus b squared equals c squared. So we have a squared plus b squared equals c squared. Now this confuses a lot of people because, oh no, how are we going to write this down? So we're going to change the formula a little bit. So we know that our c is our hypotenuse, right? But we can write that instead of c, which is our variable, we can write g as our variable. So we can write g, and then we can write our squared, and then our b and our a we can choose, like you can choose what you want it to be. So I'm just gonna call my F my A. I'll call E as my A just to make this easier for me, and F as, so you can change it and do whatever you want. So right here we have it like that. So right now what I can do is I'm given F, so we just wrote the formula in a different way because these are all still variables. So you can plug in X, you can plug in Y, whatever is given to you. So I'm just given E, F, and G, so we can just put those in the equation and just make sure that always, like always, that your G, that whatever value is, whatever variable is given to you that's on your hypotenuse side is always on the C side. So this is your base equation. But now we're going to be solving for something, so we don't know what E is. So E is a question mark right now. So we're gonna derive this formula first. So we're gonna move everything over. So we have E squared, and we're gonna subtract F squared on one side because we want to isolate it. So equals, oh, this is my bad, minus F squared. So if we minus F squared on one side, we have to minus it on the other side. So now we get E equals G squared minus F squared. So now we have our formula right here. So this is what we're going to use to solve for E. So I'm just going to erase some of this because I'm getting low on space. I'll rewrite it. All right, so we're going back. Perfect. So E squared equals G squared minus F squared. All right, so we can write down what we have first. So we don't know what E squared is, so E squared stays the same, equals, we have our G, so we know G is 24 cm. And then what I like to do is I would keep everything in brackets because this could be just be cm squared, which is not what you want. So bracket squared, and we're subtracting, sorry, this is a really bad subtraction sign. That's a subtraction sign. Minus, so our F is 13 centimeters, so 13 centimeters. And then squared. So right now we have this. And then you can square it, you can do it in your head, you can use a calculator, I guess, depending on what your teacher lets you do. So now we have E squared equals, so 24 times 24, we get 576 centimeters squared, because we square rooted everything, so cm also gets squared, minus 13 times 13, which is 169 cm squared. And then right now we can subtract these, so E squared equals, so we subtract it, equals 407 cm squared. Now we can't have E squared, so we need to get rid of it, so we can square root it. So we're going to square root E squared, and then the square root cancels out with the square, so we're left with E. But if we square root it, then we have to do it on the other side, so we have to square root this too, the entire thing. So E equals square root of, we'll just rewrite it, of 407 centimeters squared. And then, so the square root with the centimeter squared, they cancel, so it just becomes cm, so we know that it's normal. And then if we square root 407, we get, I'm going to erase the cm first because there's not enough space. So we get our 20.17421 cm. So these are all the units, these are all the numbers the calculator gave me. And now we're going to round it up reasonably. So I do hundreds place again. So E equals 220.17 cm. And make sure you have your units, and that's how you solve for Pythagorean theorem. Thank you guys for watching.